and I'm going to share the whiteboard. Okay, so we were talking about the 7th chapter, that is differentiation, and today we'll talk about chain rule. Okay, we are going to talk about the chain rule. Okay, now so far we have discussed equations of this type. Let's say we have y equals x to the power 7, or maybe y equals 1 by under root x and stuff like that. And by now we know how to differentiate such equations, right? So we multiply the existing power and we subtract 1 from the existing power, and then we get it. That is dy by dx is going to be 7x to the power 6. And for this one, I am going to rewrite y such that I get x in the numerator. This is what I would have. And now if I differentiate this, it is going to be minus 1 by 2x minus 1 by 2 minus 1. So that is going to give me minus 1 by 2 x to the power minus 3 by 2. So far we have seen such cases, and now we know how to differentiate such equations, okay? But then we have some more types as well. And for those types, we are going to use the chain rule. So let's just state the chain rule first, and then I am going to tell you when to use it. So the chain rule says dy by dx is equal to the product of dy by du multiplied by du by dx. Okay. Now in this equation, what do we see? Basically, it is saying that the derivative of y with respect to x. This is what the examiner is going to ask you. This is what you are trying to find, okay? So that is going to be equal to the product of the derivative of y with respect to u and the derivative of u with respect to x. Now, what is u, what is y, what is x? I'll talk about the question type, do not worry, okay? So let's say this is the very first example for this. It says find the derivative of y equals 3x minus 2 to the power 7. Now, so far, we did not talk about such questions. We did not talk about such examples, right? Let's see how to differentiate this with respect to x. Now, for such cases where you have a factor to the power something, what do we do? So I am interested in finding out dy by dx. This is how we denote differentiation, okay? I am going to write this as u equals 3x minus 2, okay? This is u, that is 3x minus 2, and now I will write y equals u to the power 7, okay? And now I am interested in finding out dy by dx. Now for such cases, we are going to use the chain rule. That would be dy by du multiplied by du into dx. Now, what is dy by du? What is du by dx? That is very easy. Can't we just... Yes, that is correct, Haris. That is correct. We are going to get the same thing and we can write it that way as well, but chain rule is important, and this is what chain rule is going to give you, right? Okay. But you have missed one thing. You write down the derivative of the bracket thing as well, okay? Anyways, dy by du is going to be... Now we need to follow this equation. What is the derivative of y with respect to u? So it would be 7 u to the power 6. And what is du by dx? Du divided by dx. So we got this, we are finding this. So for this, I am going to follow this equation. The derivative of this term would be 3, and for this term, it would be 0. So this is what we have. Finally, dy by dx is going to be 7 u to the power 6. What is u? 3x minus 2 to the power 6. And then I need to multiply du by dx. So that is 3. So it is going to be 21 3x minus 2 to the power 6. This is going to be the answer, right? Okay, now I will repeat. Now, either you can do it directly, okay, either you can think about such questions this way. Okay, all right. Haris, basically, आपने जो लिखा है ना, that says 7 into 3x minus 2 to the power 6, okay, you need to multiply the derivative of the power. So this derivative is wrong, जो आपने लिखा है, ठीक है, that is wrong, okay. This is the question, and how do we identify this question type? So this question type is going to have a factor to the power 2, 3, 4, 5, minus 1, minus 2, minus 3, 1 by 2, it could be anything, right? But the only difference is that unlike the old question types, this time around we have a factor and it has some power. How do we do it? We need to write down this bracket thing as u. So we write it down this way, u equals 3x minus 2. And now we have to write y in terms of u. So that would be y equals u to the power 7. That is it. What is the end goal? This is the end goal. We need to differentiate y with respect to x. Okay. So for such questions, we use the chain rule. This is the chain rule. It says dy by dx is dy by du multiplied by du by dx. I need to find dy by du. I need to find du by dx. dy by du is basically the derivative of y with respect to u. So I am going to use this equation for this thing. And 7 is in the power that would come here. I'll do 1 minus the power, and this is what I would get for the derivative of y with respect to u. Similarly, I need to find du by dx as well, because that is also used in the formula. So I will be using this equation. How do we differentiate such types? We have seen that. So the derivative would be 3 and minus 2 is constant. So that would be 0, right? So in total, dy by dx, that is the product of dy by du. So it would be 7 u to the power 6. U is 3x minus 2 and du by dx is 3. So this is what we have. I'll multiply 7 and 3. The answer is 21, and this is what we are getting. Any doubts about it? Anything that you did not understand? Yes, Munja and Haris, did you understand this?
Yes, ma'am, I did.
Okay, and what about you, Haris? Okay, all right. Now, obviously, this was the very first example. Let's talk about some more and then things would get clear. All right. So let's say we need to find the derivative. It's example number 2 of y equals minus 2 divided by 3x square plus 1 to the power 5. Okay, now how do we differentiate this? Don't worry, okay? Now just make it a practice. You don't need to use the chain rule again and again. Yes, in the background, we are using the chain rule, but try getting comfortable by doing it directly, okay? So I will first write down y as minus 2 3x square plus 1 to the power minus 5. Okay. Now I am going to differentiate this directly. Dy by dx is basically minus 2 is going to come directly. I am not going to do anything with minus 2. This is the old power that would be multiplied here. So it is going to be minus 5. 3x square plus 1 minus 5 minus 1, and then the new thing is that I need to write down the derivative of this factor. That is going to be 3 into 2, right? So that would be 6x. So finally I am going to get minus 2 into minus 5, that is 10, and then it is 3x squared plus 1 to the power minus 6, and then it is 6x. And then 10 into 6 would give me 60x divided by 3x squared plus 1 to the power 6. So this would be the differentiation. Yes, Haris and Munja, did you understand this?
Yes, I did. Thank you.
Okay, and what about you, Haris?
Before you, can I just copy this example, ma'am, before you,
Yeah,
you
sure,
delete it?
sure.
Thank you.
You're welcome.
Thank you, ma'am.
Okay, all right. So let's talk about another question now. Okay, so I'm going to clear the screen now. The question says, question number 3, the curve y equals under the root ax plus b passes through the point 12, 4 and has gradient 1 by 4 at this point. Find A and B. Okay. I'll read the question. I'll explain this to you. I'll give you some time. I want you guys to try this out. Okay. It says the curve y equals under root ax plus b passes through the point 12, 4 and has gradient 1 by 4 at this point. Find A and B. Okay. Yes. We need to find A and B, that is certain. So in maths, I'll talk about general things first. Whenever you have been asked to find the value of any variable, if you have one unknown variable, you need one equation. If you have two unknown variables, you need two equations. If you have three unknown variables, you need three equations. So the number of equations is basically same as the number of unknown variables you need to find. That is good. Okay. Now, what is the information given? I'm going to underline that we have this thing that the curve y passes through the point 12, 4 and has the gradient 1/4 at this point. So this is what you need to understand. All right. So what does this mean? This means that the gradient is 1/4. How do we find the gradient? For finding the gradient, we differentiate the curve and we plug in the x coordinate of that point. Okay. So it is y equals ax plus b to the power 1/2. I've started the solution just now. I want all of you to focus. I am going to differentiate this dy by dx. Now this is the new differentiation we have just discussed. But do not tell yourselves that this is new, this is complicated, it is easy. How do we differentiate simple cases? We multiply the power right here. We are going to do the same thing. 1/2. X comes as it is. This time around, we do not have x, we have a factor. Old power is 1/2 minus 1. And we multiply the derivative of this factor, that is going to be a only, right?
Yeah.
And this would be 1/2 ax plus b to the power minus 1/2 into a. I am going to write it down properly just so it's more understandable. Under the root ax plus b. This is the derivative. I do not have any information about the derivative. They have mentioned that the gradient at this point is 1/4. Now, what is the link between the derivative and the gradient? Now, if I plug in the x coordinate of this point in dy by dx, that is going to be the gradient at that point. Okay, so that is going to be, I'm going to plug in dy by dx at the x coordinate 12 is going to be under the root 12a plus b. So I've plugged in the value of x as 12, and what is the gradient? It is 1/4. That is it. Okay. Now this is the first equation. I am going to simplify this so I can just write down the equation. I'll just remove this. This is the equation. I'll simplify this. I'll cross multiply. This would become 4a equals 2 under the root 12a plus b. 2 and 4 can be cancelled. I can take squares on both sides just so things are more, easy. Just so I get rid of the under root sign. So that would be cancelled. 2 square is 4, a square is a square, and then 12a plus b. This is what I am going to get. This is the first equation. Okay. Now, in the very beginning of this question, I had a discussion with you guys that we have two unknown variables. In order to find both these variables, we need to have two equations. So we just have one piece of information. How am I going to get the other equation? Can anyone tell me? Yes. Any idea, Haris, Munja, Ashal? So the equations, the question says the curve y equals under the root ax plus b passes through the point 12, 4 and has gradient 1/4 at this point. We have used the only piece of information given in the question. How do I get to the other equation in order to find the value of a and b? For that, I need to use this thing and this thing. Okay. If we have
So
any,
yes.
yes.
Um, we use the same equation, but we plug in
Very good.
instead of b, we plug in 4.
Instead of x, okay, basically we have this point,
Okay, yeah, instead of x, yeah.
and we have, this is the x coordinate, this is the y coordinate, okay. This is the equation. If this is the equation and this curve passes through this point, so I have y equals under the root ax plus b. When I'll plug in the value of y and x, the equation would be satisfied because this curve passes through the point 12, 4. Okay. So I will plug in 12 instead of y, and I will plug in, I'll plug in 4 instead of y.
Mm.
So 4 equals, and then I'll plug in 12 a plus b. Okay. So this is what we have, right? So this means it's okay if I read the second equation at this point. 2a equals under the root 12a plus b. So I basically initially squared both sides, but there's no point in squaring both sides. This way I would be able to solve the equations easily, right? So this is the first equation. This is the second equation. Now we have two simultaneous equations and two unknown variables. You guys have exactly 2 minutes. Solve these two simultaneous equations. Do not get into long methods. You can directly just, cancel out the left and right sides because that's very obvious. And tell me the values of A and B that you're getting. Okay, so I'm waiting. You just have 2 minutes, and I want an answer from all of you. Even if the answer is wrong, I don't mind. Yes, Kunja, Haris, and Ashal, please tell me the values of A and B, whatever you guys are getting. Okay, very good. Haris, your answer is correct. The sign is wrong with B. Check that again, but good work. What about you, Munja and Ashal? Please tell me any idea. Okay, all right, all right.
I use the quadratic formula to solve the first part.
Okay. And
Um,
yeah,
Maybe I'm wrong. I don't know.
that's okay. What are your answers? You can tell me the answers.
9 plus b over 2, 3 plus square root of 9 plus b.
Okay, all
Oh,
right. Okay, okay.
but I was trying to find b now.
All right, I'll tell you. You know what? So at times students are quite good at maths. Like they're able to make the equations, but then they are not able to solve them, right? So I am going to tell you how to solve these simultaneous equations. Basically, we study this in O levels, but at times, students um, just fix some concepts, so that is okay. All right, so I am going to write down the two equations I have. The first one is 2a equals under the root 12a plus b, and then the second one is 4 equals 12a plus b. Okay, now this is first equation, this is the second one. Okay, now what do I see? Now I can see that the right hand sides of both these equations are same. Okay, so either I can subtract both the equations or I can divide both the equations, right? That is completely my choice. So let's do equation number 2 divided by equation number 1. So this is going to give me a new equation. I will write down the left hand side of this new equation and the right hand side of this new equation. The left hand side of this new equation would be 4 divided by 2a equals, the right hand side would be the right hand side of the second equation, that was 12a plus b, divided by the right hand side of the first equation, that was again 12a plus b. So these two are cancelled. This is why I divided, because I knew they would be cancelled. I can take 2a there. So this is going to give me 4 equals 2a, and a has turned out to be 2. Now I have one value. If I have one value, I can plug in this value, let's say in the second equation. So equation number 2 would give me the value of b. So it is 4 equals under the root 12a plus b. I can take square on both sides. So that would become 16 equals 12 into 2 plus p. Okay, so basically I've squared both sides. This would be cancelled. 4 squared is 16, and then I have 12a plus b. Instead of a, I plugged in 2. And now I'm going to make b the subject. 16 minus 24 equals b. So b is minus 8. This is going to be the answer. So a is 2 and b is minus 8. So did you understand this, all of you? Vishal,
Yes,
Harris,
ma'am.
and
It's okay.
okay, I'll
I
explain it.
tried to get rid of a square root before.
Yeah, exactly. At times the equations are so simple, and this happens with me as well. At times we think about things that, it's something very, very complicated, and then we get into, long methods, but no. In case of simultaneous equations, always try going for this method, or, we would have used this as well. This saves time. Trust me, it does. Okay. You
Okay,
could
thank
have,
you.
made a the subject in one equation one, and then you could have substituted that in two, but that would have taken much more time. I was able to do this in 1, 2, 3, 4 and 5 steps, right? But otherwise I would have done so many steps, and it could have been that I ended up getting a wrong answer, because the method would have been longer than this one. So that depends, but that's okay. With practice, obviously we will get good at simultaneous equations as well. That is not an issue. Okay, all right, let's talk about the next concept that we have already done in previous chapters, but I would like to give you a quick recap and then we'll start. Okay, now let's say this is the y-axis, and then this is the x-axis. I am going to make a random curve. Let's say this is the curve. Okay, so let's talk about this point. If I am interested in finding out the gradient at this point, I am going to, yes, I'm going to differentiate this, but the gradient of this point would be same as the gradient of this tangent line, right? So this line is basically the tangent line. And what is the normal line? The normal line is perpendicular to the tangent line, and it is going to be something of this type. So the angle would be 90. The only thing I want to tell you is the relationship that we have studied in perpendicular bisectors. Okay. So obviously this is not a perpendicular bisector. It's just this that two lines are perpendicular. So if the gradient of the tangent line is m, the gradient of the normal line is, let's say, m perpendicular. We have discussed this already, that the product of these two gradients would be -1. Okay. Now, the questions which we are going to discuss shortly are basically going to be of this type. So you can easily, well, let's say that you have been asked to find the equation of the normal line. Okay. We have studied that as well, how to make equations. In this chapter, since we're talking about differentiation, so differentiation would help us find the gradient of the tangent line. And once we have the gradient of the tangent line, we can use this formula to find the gradient of the perpendicular line and then find the equation easily. Did you understand the basics? The only thing I want you to understand is that the tangent line would be a line of this type. The perpendicular line or the normal line would be a line that is perpendicular to the tangent line, and the relationship. Whatever gradient you are getting for the tangent line, the negative reciprocal would be the gradient of the normal line. For example, forget this formula. We don't have this much time, okay? Let's say the gradient of the tangent line was 2. The gradient of the perpendicular line would have been the negative reciprocal, -1/2. Let's say the gradient turned out to be -1/3. So the gradient of the normal line would be the negative reciprocal, that would be 3, right? Are you getting my point? The relationship between these two gradients? Yes, Sishal, Haris, and Munja, please tell me.
Yes, ma'am, I do get it. Thank you.
Okay, very good, Shal. And what about you, Haris? Please tell me. Okay, all right. So, Haris, the thing is that we have discussed these contents earlier as well, where I told you the relationship between the gradients of the normal or the perpendicular line and a simple line, right? I told you if we have two lines, let's say this is a line and this is another line, and if these two lines are perpendicular, there was a relationship in their gradients. So let's say this is m1, this is m2. The product of m1 into m2 was -1. In short, whatever gradient you were getting for m1, the negative reciprocal was the gradient for m2. This is what we have discussed. The purpose of discussing this again in this chapter is that now we know the link in differentiation and gradient. Okay, I'll plug in the x coordinate in the derivative, and that gives me the gradient. So basically, through differentiation, I would be able to find the gradient of the tangent line. And once I have the gradient of the tangent line, I would be able to find the gradient of this normal line. So that is the concept. Let's say this is the point. So this is going to be the tangent. It is going to touch at pink dot only. And the normal line is going to be a line that is perpendicular to this pink line. So it would be something of that sort, right? So I can find the gradient of the red line using the concepts of perpendicular lines. Okay, very good, Harris. Right. Now I'll write down the question and then things would get even more clear, okay? Please be attentive, all of you, because this is extremely important. Okay, it says, question number 4, it is find the equations of normal and tangent lines to the curve y equals 2x square plus 8 by x square minus 9 at the point where x is 2. Okay. Now I'll tell you. Okay, now this question is a bit difficult because they have shared less information. I'll tell you. Find the equation of the normal and tangent lines. Okay, so we need to do this thing. And what do we have? We have the equation of the curve and we have the x coordinate at that point. Okay. Now, first thing should be clear. In order to find the equation of any line, even if it's normal, tangent, straight line, horizontal line, vertical line, whatever it is a line. We, in general, the formula is y minus y1 equals m x minus x1. Okay. Now let's say if I talk about the tangent line first, if I am interested in finding out the tangent line, I need three things. I need the gradient of the tangent line. I need a point on the tangent line, and I basically need the x coordinate of that point. It could be any point on the tangent line. Okay. And I need the y coordinate of the same point that I am using. Okay. Now, obviously, you cannot use any point because you just know that the normal and tangent lines are basically passing through x equals 2, because this is what the question says. They are saying find the equation of the normal and tangents to the curve y equals this at the point where x is 2. Okay, so I did not write down, but this is what we know. Okay, x is 2. So the x coordinate is 2. We need to find the y coordinate. We need to find the gradient. We already have the x coordinates. Okay. Now I am going to visualize this through a random example. Let's say, for example, this is the curve. Okay, I'm just giving you an example. So this is going to be the tangent line, and this is going to be not this one. It should pass to the same point. This is going to be the normal line. Okay. So for any line, what do I need? I need a point. That point would have x coordinate and y coordinates. I'll plug those values here. And what else do I need? I need the gradient. So how am I going to get the gradient of the tangent line? Can anyone tell me?
The
Yes.
gradient.
The gradient of this line.
Are we not going to maybe differentiate the line of the curve?
Yes, we will differentiate the curve, and very good. And how do we get the gradient? Differentiation would just give us the derivative. What is the link between gradient and derivative? I've been telling that so many times. Yes, Haris and Rashal, please tell me. Any idea? How do I get the gradient of the tangent line? All right, so let's see. Yes, gradient of that point 2, you use dy by dx. Okay, all right. So basically, step 1 is going to be to differentiate that. Okay, so this is the curve. I will differentiate this. Once I have the derivative, once I have dy by dx, I am going to plug in the x coordinate, and then I would get the gradient. Okay, because dy by dx would give you the general derivative throughout the curve. It would be the derivative at this point, at this point, at this point. In order to find the exact gradient, you will plug in the x coordinate at this point, at this point, at this point. And for now, we are interested in this point only. So I will plug in the x coordinate, that is x equals 2. Okay. So, excuse me. I know that I need to differentiate this. So first I am going to write down the derivative properly. So let me just make some lines just so we are able to do it properly. Okay. Now, in order to differentiate this, step 1 would be to rewrite the equation with all the x's in the numerator. Okay. And then dy by dx is going to be 2x square would become 2 is multiplied. That would become 4x. 2 minus 1 would be 1. Minus 2 into 8 would be minus 16. X to the power minus 2 minus 1. That would be minus 3. And the derivative of any constant number is 0. So we do not write that. Okay. This is the derivative. Try to understand the relationship between the derivative and the gradient. I get the gradient at exactly this point by plugging in this x coordinate. So the gradient at x equals 2 is 4 into 2 minus 16 2 to the power minus 3. What is this exactly? It is basically the derivative, and instead of x, I've plugged in the x coordinate. And this will give you 4 into 2, that is 8, minus 16 divided by 2 to the power 3, and that would give you 2 to the power 3 is 8. So it is 1 times, it is 2 times. So 8 minus 2 is 6. This is the gradient of the tangent line. So now I have the gradient of the tangent line. Let's just try finding out the equation of the tangent line. In order to find the equation of any line, how do we go about it? Y minus y1 equals m x minus x1. This is the equation that we use again and again. Okay. Now I need y coordinate of any point on the tangent line. I need the gradient and I need the x coordinate. So I have the gradient and I have the x coordinate, that is x equals 2, but I do not have this y coordinate. What is going to be the y coordinate when x is 2? Yes. What is the y coordinate when x is 2? This is your equation.
We use the first equation.
Very good. And we plug in the value of x to get y, right? So can you please find the value of y, all of you? Y is going to be?
Y is equal to x. I find 1.
Very good. Y is 1. Okay. Now we have everything. We just need to plug in the values. So y minus y1 would be 1. M is the gradient, that was 6. X minus x1, that is 2. I need to simplify this. So that would be y equals 6 into x is 6x minus 6 into 2, that would be minus 12. Minus 1 would be taken to that side. It would become plus 1. Y equals 6x minus 11. This is the equation of your tangent line. Okay. We are done with the first part. The second part says equation of the normal line, and trust me, this is a very, very important question. You'll get to see this question multiple times when we start past papers, right? So this is extremely important, right? Okay. So equation of the normal line. Again, this is a line. I'll write down y minus y1 equals m x minus x1. This is how we find the equation of any line. We need y1, we need m, we need x1. So let's say this is a curve, this is the point, the tangent line is this one, and now we are working out the equation of the normal line. So this is the normal line. The coordinates of the tangent line turned out to be 2 and 1. So don't you think that the normal line is passing through the same point? Yes, it
Yes.
certainly
Yeah.
is. Okay.
Mm.
So we have y1 and x1, and that would be same as we had for the tangent line. The only difference is for m. So for this, we are going to use the relationship of normal and tangent lines, which I told you before starting this question. Now, think about it and tell me what is going to be the gradient of this normal line, given that the gradient of the tangent line was 6.
Minus 1/6.
Very well done. Excellent. It would be the negative reciprocal. Very good. So y minus y1, that is 1, equals the negative reciprocal of the gradient of the tangent line, that was 6. So the negative reciprocal of 6 would be minus 1/6, x minus 2. I'm going to simplify this, minus x by 6 plus 2/6, that would be 1/3 plus 1. And now I am going to simplify this, so that would give me y equals minus x by 6, and then we have 1 divided by 3 plus 1, that is plus 4/3. Yes, Haris and Ashal, did you understand this? All of you, Munja as well? Please be
Yes, ma'am.
honest with yourselves. This is one of the most important questions, okay? All right. And what about you, Haris? Yes, Haris, please tell me if you're okay with this or not. Okay, not the last part. Okay, all right. So that is good that you have asked this, because as I was telling you already, this is very important, okay? Now, I assume that you have understood how to find the equation of the tangent line, and this is the problem. Okay. Now, again, we need to find the equation of a line, okay? Equation of any line is basically written in this form. We need a point on that line, and we need the gradient of that line. Now we know that, let's say this is the tangent line, this is the normal line. The point would be same, okay? So if we are using 2, 1 for the tangent line, we can use 2, 1 for the normal line as well, okay? So that is good. The point would be 2 and 1. So I've plugged in 2 and I've plugged in 1. The fact that the gradient is minus 1/6 is basically coming from here. The gradient of the tangent line was 6. We know that if two lines are perpendicular, we have a relationship in their gradients. The gradient of the second line would basically be the negative reciprocal of the first line. So these two lines are perpendicular, 6 is the gradient, so it would be minus 1/6. Okay, very good. It's clear now. Perfect. Okay. This was the question. So we are done with this. And now let's talk about the last part of this chapter. That is second derivatives. Now this is extremely easy. You won't get to learn new stuff here. If you know how to differentiate for the first time, you can easily differentiate it for the second time, right?
Yes,
So
ma'am.
first I'll write down the two symbols. Okay. dy by dx is basically the first derivative. d2 y divided by dx2. This is the symbol for second derivative. What is second derivative? So let's say you have an equation and you have been asked to differentiate that, okay? You have been asked to find the second derivative. So first you will find the first derivative by doing simple dy by dx, and then you will differentiate dy by dx to get the second derivative. For example, let's say question number 1. Let's say you had y equals x cubed plus 2x squared plus 4x. This is the curve, and you have been asked to find the second derivative of this curve. How do you do it? Okay. So it is going to be dy by dx. That is, how do we differentiate this? 3 is going to come here. 3x squared. 2 would be multiplied with the coefficient, that is 4x plus 4. What was the question? The question was to find the second derivative. Now you are going to differentiate this equation. So first I am going to write down the symbol d2y divided by dx2. This is the only new thing that you need to remember. That is it, okay? So be clear with these twos. And this is equal to 2 into 3, that is 6x plus 4. Very good, Haris. Excellent. This is going to be the answer. All right, perfect. And now I'll write down a proper question and let's do that. Okay, so it says, okay, so you guys can take a 3 minutes break if you want to. Meanwhile, I'll write down the question, okay? Okay. What is the question? So it is, a curve has equation y equals x cubed plus 3x squared minus 9x plus 2. Find the range of values of x for which dy by dx and d square y by dx square are negative. Now this is easy. We are going to find dy by dx and the second derivative first, and then I'll tell you the next steps. Okay, so let's do it. All right. Let's talk about the solution of this. So dy by dx is, we are going to refer to this 3x squared plus 6x minus 9. Okay, be very careful that I write down everything correctly. It could be that I write something wrong and then I would want you guys to be active and tell me. Okay, please be active because you just have 1.5 months left in your exams. Okay, and this is dy by dx. Okay, and then if I talk about the second derivative, so that is 2 into 3, that is 6x plus 6. Okay, these are the two derivatives, first one and then the second one. What exactly is the question? The question is to find the range of the values of x for which dy by dx and the second derivative are negative. So they want us to find the values of x for which dy by dx is less than 0. I am going to write down the value of dy by dx that I got. So it was 3x squared plus 6x minus 9 less than 0. And how do we solve quadratic inequalities? We discussed this in the first chapter. Okay, first I'll take 3 common just so it becomes a simple equation. X squared plus 2x minus 3 less than 0. Now I am going to factorize this, and the two factors would be x plus 3 and x minus 1 less than 0. And what next? We have discussed this. Never ever try solving this directly. Always make the graph and then think about it. So the intercepts are x equals minus 3 and x equals 1, and it would be a U-shaped parabola. So it is going to be something of this type. Okay. And now what values of y do we have? We have less than sign. So less than sign means we are going to refer to the negative values. So this is basically, I won't write this thing down, you will get confused. Okay. For now, just focus on this. Forget about that we are studying differentiation, we are doing this, we are doing that. We are just interested in solving this inequality. How do we solve quadratic inequalities? By plotting the graph. Now this factor is less than 0, so we will talk about the negative values of y. So they are referring to all these points that are basically below the line of x-axis. So basically all these points are going to be included in this range. Okay, so x should be greater than minus 3 and it should be less than 1. Okay, this is what we are getting for dy by dx. Let's check what we get for the second derivative, because we have the condition on that as well. It says second derivative should also be less than 0. So the second derivative is less than 0. The second derivative was 6x plus 6 less than 0. I can take 6 out and this is what I am going to get. So x is less than minus 1. All right. This is what I am getting. Now, what exactly was the question? Find the range of values of x for which this and this are negative. So we need to find a common range and then talk about the answer. So I'll make a number line. This is minus 3, 0. This is 1. This is minus 1. For dy by dx less than 0, the range is this one. And for The second derivative less than 0, the range is this one. It's going on continuously. And we are going to pick up the common range that is going to be this. Okay, that is between -3 and -1. This one. All right. So I'll repeat the question. I'll explain this again. Basically, this was a general maths question. You had to find the range of values of x which were satisfying two things. Dy by dx should be less than 0 and the second derivative should also be less than 0. So step 1 was to find dy by dx and the second derivative, and then we had to find the two inequalities. Okay, so basically both these derivatives are less than 0. For dy by dx, we had a quadratic equation. In order to solve quadratic inequalities, we are always going to make the graph and then talk about the range. And for the second derivative, we were getting that x is less than -1. The question had and in it, okay? The question had the word and. When we have and, we need to pick up the common region. So the common region would be that x is greater than -3, but it is less than -1. Do not answer this question with two ranges. You are going to give one range only because of the and thing. Did you understand this, both of like all of you? Yes, Munja. Okay, Haris is saying
Yes, I
yes.
did, ma'am. Thank you.
Okay, welcome. And what about you, Ishal? Okay, very good. Now I'm going to stop sharing this and we are going to do the last thing. I'll stop the recording.